So let's look now at the properties of logarithms. And we're going to use these properties so we can actually determine the rules of logarithmic functions, and this will allow us to simplify and solve logarithmic functions and equations. Now we have to keep in mind that a logarithm is just the inverse of the exponential function. Remember, y equals b to the x is the same as x equals log base b to the y. We can switch those around. So the inverse of the exponential function, we can reverse those around. And just like we have rules for exponents, there are rules that are provable for logarithms. And that's what we're going to do in this lesson, is prove the rules for logarithms, also known as the log laws. Now, we always have to keep in mind is we're going to be choosing bases, and the bases must meet this criteria: greater than 0 and not equal to 1. So let's look at one of the first rules for logarithms, one of the first log laws. Well, what if we have a logarithm of some base, and we don't care what the base is, but the argument is 1. We want to find out what does that equal. And we don't know what it equals, so we're going to use a generic x here. Well, we can use our rule from switching from logarithm to exponential and just say this is the same as b to the x is equal to 1. So we can write the number 1 as whatever base we like, as long as it has an exponent 0. And so what we have is b to the x is equal to b to the 0, which means x must equal 0. And that leads us to our first rule for logarithms. Log of any base, when the argument is 1, the solution is always 0. There's our first rule that we're going to use. Well, what if we have a base and an argument that are the same? Log base b of b is equal to x. What do we get in that case? Well, let's use our rules for switching from logarithmic to exponential. B to the x, and let's be specific here. This b is the base. B to the x will equal whatever the original argument is, b. Now we have to remember that if we just write the letter b, that's really the same as writing b to the 1, which means x equals 1. And that takes us to our next rule for logarithms. When a logarithm with a base and an argument are both the same value, it's always going to equal 1. There's our second rule for logarithms. Same base as argument, it's equal to 1. Well, what if we get into some more complex rules? And let's look now at the product rule for logarithms. And when we do these proofs, we're going to compare to exponents, exponential functions that we already know. So we're just going to say x is equal to some exponential base b to some exponent m. And we're going to use variables so we can prove it for any value. And we're going to do another value y, same base. We always want to keep the base the same. We don't know what the exponent is. And we're going to use this as well as switching it from exponential to logarithm. So if we switch this, we would have an equation m equals log base b of x and n equals log base b of y. And we're going to use these interchangeably to figure out the product rule for logarithms. What happens if we multiply x times y? And x times y is really just the same as b to the m multiplied by b to the n, just using our exponential form. Well, we know our rules for exponents. We would add these exponents together, and x times y is just xy. And there we have x times y in exponential form. But let's switch it from exponential to logarithmic form. In logarithmic form, this would be log base b of x, y is equal to m plus n. Just switching that around. But now look up here, we have values for m and n in terms of logarithms, and we can just replace those. So that'll leave us with log base b of xy is equal to, our m value was log base b of x, and our n value is log base b of y. And that is our product rule. When we have a logarithm with two numbers multiplied together, x times y, it's the same as the sum of two logarithms to the same base. Log base b of x times y is really the same as log base b of x plus log base b of y. Let's put it into practice. We're just going to use our rule here for logarithms. Well, when we have two logarithms and they are the same base 2 here, we know our new rule is we can just take those logarithms, write them to the same base 2, and turn it into a product, 5 times 7. And so if we were simplifying this, that's really the same as log base 2 of 35. There is our way that we can combine the sum of two logarithms into a product and vice versa. Well, let's use this same idea to determine the quotient rule. And just like before, we're going to start with two exponential functions and be able to switch them to their logarithmic form. But this time we're doing the quotient rule. So what happens if we take x and divide by y? Well, this is just the same as b to the m over b to the n. There it is in exponential with base b. Remember our rule for exponents. If the base is the same, we would subtract the exponents. So y over x is equal to b to the m minus n. Now we're going to take it and write it in logarithmic form. Log base b of x over y is equal to m minus n. And just like we did before, we switch the m and the n, and we'll get log base b of x over y is really the same as log base b of x minus log base b of y. Our quotient rule. When we divide an argument, we become a subtraction of logarithms. Much like exponents, division is subtraction. There's our quotient rule. And we can apply this quotient rule to a situation like this. Log base 2 of 24 minus log base 2 of 8. We can write it as a single logarithm. And this tells us that the numerator is 24 over 8. Keep in mind, that's the entire argument, 24 over 8, which we can then simplify down to just the number 3. Log base 2 of 3. That's the same as log base 2 of 24 minus log base 2 of 8 is just log base 2 of 3, using the quotient rule. So that's if we have addition or subtraction or multiplication or division. What about the power rule? And we had a power rule in exponents, we have a power rule in logarithms, and this time we're just going to start with x equals b to the m. One exponential function, and with this exponential function, we're going to take it and we're going to put it to some exponent. So let's just put it to some exponent a, and as long as we do the same to both sides, we don't change anything, we'll just put it both to the power a, or exponent a. That'll give us x to the a equals b to the, and I'll just write it as ma. Well, now we can take this and we can switch it from logarithmic to exponential. And we want to switch it to base b. So log base b of x to the a is going to equal m times a. Now, since we started with x equals b to the m, the logarithmic form of that, if we solve for m, is really just the same as log base b of x. And once again, we can switch that m down here into log base b of x. And I'm just going to move the a to the front, multiplied by a. Log base b of x to the a. And that leads us to our power rule. When we have a logarithm of any base with an argument to any power a, that's equivalent to taking that power out in the front and just writing it as log base b of x. A very powerful rule in logarithms. The exponent in the argument really just comes down in front. Now let's use this in a question. Log base 2 of 16. And what we're actually going to do in this question is use a couple rules, including our rules for exponents. Well, log base 2 of 16 can also be written as log base 2 of 2 to the 4. 16 is the same as 2 to the 4. Now, if we use our power rule, the 4 is going to make its way to the front. So this is really the same as 4 times log base 2 of 2. And we have to remember, we have a rule when the argument and the base are the same. Argument and the base are the same is really just the same as writing 1. So this whole value is just 4. So log base 2 of 16 is really just equal to 4. And we're going to do more and more of this, of using our rules for logarithms and interchanging them. But let's look at one more rule. Change of base rule. Well, to the change of base rule, we're going to start the same way we started before. Let's start with x equals b to the m, and that's really the same if we wanted to solve it for m in logarithms of log base b of x. So we're going to use this interchangeably. We're going to start, though, with our exponential function. And this is something we're going to do in logarithms all the time. X is equal to b to the m. I'm going to leave a space there because we're going to log both sides. We're going to take this side and write it as a logarithm to some other base. In this case, we'll just do it base c. And as long as we log both sides with the same base, we're doing an equation, doesn't change the equation. So log of some other base c to the x is the same as log of that same base c of b to the m. Now this gets us into a new base. Well, we can use our rule for powers. That m will actually come down in front. And we'll say it's log base c of b times m is the same as log base c of x. And now let's solve this for m. If we divide both sides by log base c of b, this will get m by itself. And I'm just going to change it around so we have m on the other side. Log base c of x over log base c of b. But remember, m was the same as log base b of x. So we can change that m to log base b of x, and it'll equal log base c of x over log base c of b. And this is a very powerful rule to change the base. And notice what happens to the base. The base in our logarithm drops down to the denominator, and we can write it in any other base as a fraction, a log over a log as a fraction. And where we use this rule all the time is when we start to use our calculator, start to do calculations of logarithms. So let's just do our change of base rule here. Log base 3 of 7 is really the same as log, and I'm just going to put it in as c for now, of 7 over log base c of 3. There's our change of base rule. We can choose any base we like. Now, if we want to put this into our calculator, the calculator only works in base 10. So what we do is change our c value to base 10. Choose a base of 10. And in that case, what this really just becomes is log base 10 of 7 over log base 10 of 3. And remember, we can write log base 10 as just log, and we get log 7 over log 3. And if you look on your calculator, you have a log button, and all you have to do is type that in. Log 7 over log 3, and you'll get a value to 3 decimal places of 1.771. There's our value. And that's how we use our calculator and logarithms when they're not in base 10. We just change the base to base 10. So what we're going to do is use all of these rules for logarithms, these laws of logarithms, to simplify functions and solve logarithmic equations. Now, there are going to be some other adaptations we'll make to these laws, but these are the basic 6 that we must commit to memory and know how to use, and we're going to spend a number of days in class working with these laws of logarithms.